going to start to look at now is a process called chromatography. And chromatography is used to separate components in a mixture. So you've got a mixture of chemicals, and the easiest one for you to think about from studies that you may have done at school is the separation of the colours of different dyes in the inks of a felt tip pen. You would have spotted the felt tip pen on a piece of filter paper and then put the bottom of the filter paper in some water and allowed the water to rise up and separate out the colours of the pen. Now it works because the different inks in the pen are different chemicals, and those inks in the pen will either like the paper or the water that's moving them different amounts. So if they like the paper a lot, they will stick to the paper earlier on and they will not be able to be moved, and so they will not move very far up the paper. Now those dyes that don't really like the paper, so they maybe can't make any kind of intermolecular force with the paper, will like the water phase more, and they'll move further because they'll continue to move with the water because they like being in the water. So it's this balance between how much you want to dissolve in the moving phase and move compared to how much you want to be retained, stick to the stationary phase and stay still. That's how chromatography techniques work. So we need to look at all those key terms. So the first key term there is we're using a term called phase, because we have a stationary phase and a moving phase, and a phase is just a state of matter like solid, liquid or gas. So we'll be pointing out what the stationary phase and moving phase are made out of in all of our techniques, and we'll be thinking about whether they're a solid, a liquid or a gas. So the moving phase in chromatography is simply the phase that moves. So in the case of separating pens on filter paper, it was water moving up the filter paper. And the stationary phase is the phase that doesn't move. So in that example, it's the paper. Okay, so at school you may well have done some paper chromatography. So how does it work then? How are components separated? So it depends on this balance between solubility, your ability to dissolve into the moving phase, compared to your ability to be retained, stick to the stationary phase. And it's a balance. Some things will like the stationary phase more, some things will like the moving phase more, but everybody will be retained eventually if you choose the correct combination of things. So you will be able to locate all your components if you have the correct combination of stationary phase and moving phase. So we've got different types of stationary phase at A level. At GCSE you will have only probably come across where your stationary phase is a solid, the piece of paper that you might have used for your chromatography. So if the stationary phase is a solid like that, then the separation depends on the balance between the solubility in the moving phase, so how much we dissolve in our moving phase, and the retention by that piece of paper, or as we move into A level we'll see some chemicals as our stationary phase. But we've got that solid stationary phase. That stationary phase is going to retain by a process called adsorption, which is sticking to the surface, like you would call a Pritt stick an adhesive. So you stick with it, you're going to stick to the stationary phase. Now the stronger the retention to that stationary phase, the slower the component will move with the mobile phase. The mobile phase is going to always be moving, the stationary phase is keeping still, and the stronger that you retain to the stationary phase, the more difficult it is for that moving phase to move you. It's like a Velcro ball on a Velcro wall. It's very difficult to move, so you have to push it quite hard. Notice the wording, it's very repetitive, it's very important to get this wording correct. If your stationary phase is a liquid, which we're going to come across in something called gas chromatography, and you're thinking, well, the word's gas, well that's because the moving phase will be a gas. But if our stationary phase is a liquid, then we still have this same principle. Separation depends on the balance between solubility in the moving phase and retention by the liquid stationary phase, but because our stationary phase is not a solid now, it's a liquid, to be retained we're going to have to dissolve into the liquid, so that is going to be by solubility. And again, the stronger the retention, the slower the thing is going to move. This rate of movement is recorded by either something called an RF value, which you probably have measured at GCSE on your piece of the paper, or by a retention time, which is probably a new concept to you, and we're going to look at those. And the things that will affect this balance is things such as polarity, because quite often your stationary phase has got polar molecules on it, so if it's also polar, my component, it might like the stationary phase more. So it's going to be affected by things like the polarity. So that's just a little introduction to how chromatography works.